Hello everyone. In this video, I will showcase how NVMe commands can be executed over the I3C protocol using the PGY-I3C-EX-PD platform. NVMe, that is Non-Volatile Memory Express, is a modern storage protocol designed for solid-state drives optimized to take full advantage of high-speed PCIe interface. For this demo, I have connected a standard NVMe compliant SSDs to the PGY-I3C-EX-PD unit. The PGY platform allows the user to interact with the drive, send different NVMe commands and view response in real time. To begin, I will click on Check Hardware Connection icon to establish the communication. Next, I will load the previously saved device network, which includes one Prodigy controller and one external target device with DCR type set to MCTP. I will then select the controller option to generate the I3C traffic and click on Start Capture button to capture the data. The results will be displayed in the decoded result window. Next, I will assign the dynamic address to the target device using the ENTTA CCC. I will click on Run button. So in the decoded result, we can see the command has sent and the controller has assigned the dynamic address as 8 to the target device. Before sending an NVMe-MI or MCTP request packet, I will configure the Prodigy controller to generate the read response by loading MCTP response script. This ensures the controller is ready to issue the correct response immediately after an event is triggered. First, I will perform MCTP initialization before sending NVMe-MI command. So I'll load MCTP set endpoint ID and get the endpoint ID. Next, I will load NVMe read MI data structure command. So this is how the NVMe-MI command structure looks like. These are the MCTP transport header, which includes hardware version, destination ID, source ID, start of message, end of message, packet sequence, tag owner and the message tag. Then following this, MCTP packet payload is transmitted. It begins with MCTP integrity check bit, which indicates message is protected by overall payload integrity check. So for NVMe, I have set this bit as true. Next comes message type, that is NVMe-MI over MCTP. Next, request bit, ROR, and NVMe message type as NVMe-MI command. So here there are three different types, that is NVMe-MI command, control primitive and then admin commands. So next, CSI stands for command slot identifier. You can set either it as 0 or 1, true or false. CIAP, then MEB, then NVMe-MI command. So here we can choose the NVMe-MI commands. Then comes the data. So in the data, we can specify the 4 bytes of dword 0 and then next 4 byte as dword 1. So I'll click on Run. So in the decoded result, we can see the target has responded with the response as success, and we can see the NVMe management response data length is set to 20 and then the major version, then the minor version. And then at the end, we can see 4 bytes of message integrity check, CRC32, and then followed by a PEC byte. If the data structure byte is set to 0, we will get the information about NVMe subsystem device. If the data structure type is in a request is set to reserved byte, that is other than any defined byte. So if I set it to FF, reserved byte, the command shall complete with the invalid parameter error status. In response to that, we got the result as invalid parameter. In the response, the packet error location will specify which field or the byte position is wrong. So we can see it has returned as B, that is the 11th position. The bit position is wrong. Users can send multiple request packets in a single run and verify the corresponding responses. For example, the first NVMe command is sent over command slot 0, and I'll send one more request command with command slot identifier to 1. So here we can see we got the two response packet, one over the command slot 0 and another with the command slot identifier as 1. And to send other NVMe-MI message type, that is control primitive, user can go back to the NVMe message type and select control primitive command and select the rest of the fields, and I'll just select NVMe pause command and enter the data bytes and click on run. So we got the response as success for the pause command, control primitive command. Similarly, user can send the admin commands. So I'll just load one example for NVMe admin command, that is identify command. So this is a script for NVMe admin command, where I have selected the NVMe message type as NVMe admin command and entered different data words. Since the first request packet exits over the 64 byte, I have splitted the request packet into two, and in which the first request packet has EOM has false and the next EOM packet is true. That means the end of the request packet, and we got a response as success. In the response packet, the response was set to 20 bytes, so the response data is 20. So in the D length, we can change the response data. So you can send a data length with 256 bytes, and we can see the response data. And similarly, if any of the packets are long, like if I set the IC bit as false, the target will silently drop the response packet. If you have entered less number of data bytes, the SSD will return the status as invalid command size. So this is how the NVMe commands are encapsulated within the MCTP frames and transmitted over the I3C bus, enabling the real-time interaction with the SSDs. This layered communication stack ensures the reliable device discovery, message routing, and protocol compliance. With the Prodigy's API support, users can go beyond the basic validation and perform advanced stress testing, automating command sequence, stimulating edge cases, and verifying the robustness under the load. Thank you.